we now have our panel question and answer session. Our first question is for Thomas, and is how does drought affect these interactions, and should interacting systems be managed differently under drought conditions?
Very, very good question. Certainly the drought has huge impacts on these systems in that, in California and in the southwest of this country, in two ways. One is you have decreased stream flow because the precipitation is simply not there. To the degree that your base flow, the contribution or the part of stream flow that comes from groundwater is less than months to a couple of years old, that part will also be less because as a result of drought, you have less recharge going into your aquifer system, which is not unlike increasing pumping, has the same effect on stream flow somewhere down the road, with some of those effects not being seen for many years, as Bill just highlighted. But the other piece that we have in California and elsewhere in the Southwest is that as surface water becomes less available, precipitation is not available, people turn to groundwater as the alternative source for water, and much of the Southwest, either seasonally or in periods of drought, has come to rely on groundwater as a resource to continue doing what we're doing and thrive economically in ways we do in normal and wet years. To the degree that that impacts stream flows, that does mean that if we want to avoid these low stream flows, we need to work on ways to either increase the amount of recharge to our aquifer systems during times when we have that water available, and use the aquifer essentially as an intermediate storage, increase stream flows from other surface water resources, which is the case in the Scott Valley, where the Scott Valley Water Trust actually buys surface water from diverters to put that into the stream during critical low flow periods, or decrease groundwater pumping at strategic times. Those are the options.
Great, thank you for that. Our next question is for Bill, and someone has asked, how do contaminants shift back and forth between ground and surface water, and is there a delayed release of pollutants at all?
Okay, yes, so it depends to some extent on whether the stream, as Ken showed, whether the stream is a gaining or losing stream, which way the contaminants are moving. And the important point is that contaminants can move from surface water to groundwater, or they can move from groundwater to surface water. So let's take the first. One of the concerns about the movement of surface water to groundwater is that groundwater provides a filtering system for things like microbial contamination. And so you do have systems where you have a well close to a river where the water that the well is pumping is largely coming from the river with a very short time delay, and these are known as groundwater systems under the influence of surface water, where in this case under the influence is a bad thing because you're not getting enough of the protection, and those systems actually have to be disinfected before use, whereas not all the groundwater systems have to be so. The contaminants moving the other way depend upon. I think one of the things that you can't emphasize, which is very important, is there's a typical zone between the surface water body and the groundwater system, and this is true in both lakes and rivers and wetlands, where you have a lot of organic material. You have a lot of interactions that take place, so it's not a simple matter of just taking a few groundwater quality samples and that's your surface water quality from the discharging system. There's a lot that happens in that range, and essentially one has to think about not just the temporal scale, but again some of the spatial scales of how some of these systems work in a very close, in a very narrow environment there. And then, as I showed with the nitrate, you can have very long buildups of nitrogen. Nitrate's a particularly good example because there's just it's sort of a creeping problem that eventually affects not only your groundwater system but your surface water systems as well, where it has in the surface water system ecological effects.
Great, thank you for that answer. We've got another question that's come in, and it is that regarding the misconception number 4 that was talked about earlier on the impacts of pumping from confined aquifers on base flow from your presentation, Ken, can anyone elaborate on how pumping from a confined aquifer can impact a stream's base flow?
Okay, Charlotte. So the question is about if you're in a confined situation, how does that affect stream flow? And I guess the answer I would give is that every aquitard or what are often called confining units that I've ever seen has some leakage through it, and so when you pump below that, you're reducing the head or the hydraulic pressure, the hydraulic head below that unit. That's going to eventually induce some flow through the unit unless the unit is extremely tight. But almost every aquitard I've ever looked at does have some leakage or flow through it. And so the amount, so that change in pressure is going to be transmitted up to a shallower aquifer, and from there it could possibly influence the stream. So the impacts are going to be probably delayed more for a longer time, and those can be calculated. The best tool we have would be groundwater flow models these days for doing that. It could be in some cases a very minor impact, in other cases a more serious impact. And remember that just because you have an aquitard, we've done a lot of work on aquitards here in Wisconsin and elsewhere, and aquitards have there's many ways that water can get through them. One of the most important that people forget about are wells that penetrate them. If there's an area where there's a lot of wells have been drilled, and particularly if they're poorly or not completely cased, or if the casings are very old, you can get a lot of leakage down the casings. And so we call these cross-connecting wells or cross-connecting boreholes, and that's another way that you can transmit the effects of deep pumping up to a shallow aquifer. So those are my thoughts. Bill or Thomas, you may have other things to add to that question.
Great, thank you for that answer. Our next question is for Tom. Thomas, what has been most valuable in getting collaboration between different interests in the Scott Valley?
Great question. In my experience, it's communication, communication, and communication. Groundwater and this connection between groundwater and surface water is something that we can't readily see, and it's often misunderstood because we can't look at it and really understand it. And so talking to folks and communicating how the system works and understanding the system and communicating that understanding in terms that lay people can understand has been a really important part for our work in the Scott Valley, and has been not just in the Scott Valley but elsewhere as well. One of the most important tools to get people to engage and take ownership of managing the problem and finding very creative solutions in addressing the issues that we as scientists often haven't come up with in the first place. So this back and forth between various stakeholders, regulatory agencies, and scientists, staying engaged, communicating is an important piece to moving forward with creative solutions.
Great, thank you. Another question that's come in, and it's directed at Bill, is how do you convince citizens that nitrogen reduction measures need to be started when they won't see the impacts in their lifetimes?
Okay, that's a good question, actually. First of all, there will be some impacts because there are also surface water impacts as well as direct surface water impacts. I think the best way, as Thomas just mentioned, is communication, communication, communication. Basically, you have to demonstrate to people that the effects will be felt ultimately, and what the consequences are of not taking any action today. In other words, for example, Thomas gave the example of California new Groundwater Management Act. Some 40 years ago, when we had the same governor in California we have today, those same ideas were put forward, and if we had acted on them then, we would be in a lot better situation today. So it's a matter of convincing people that the no action alternative is not a good one, and you have to take it, the sooner the better, to start your way down the right pathway.
Great, thank you. And I think this will be our last question for the day, but will apply to all presenters. And it is, what kinds of changes can states and communities make now to help sustain the groundwater supplies in coming decades?
Well, I would say, first of all, have a good inventory of use. And some states I know are better than others about that. But first of all, understand where and when groundwater is being used, so that you have a good record of water use. And then you can develop calculations or models to help understand how this use is impacting the resource. And certainly there are many situations where the impacts will be minimal or not terribly significant. Others where they'll be very significant, and you need to deal with the significant ones and maybe encourage development of pumping in the places where the impacts are not going to be so great. And as we've heard, that those are places farther from the surface water features, places where the aquifer hydraulics, the properties of the aquifer are going to make the hydraulically the impacts be less. Those are the first things that come to my mind.
This is Bill. Ken took my answer, so I'll have to come up with a new one. But I do think getting a handle on use is really important. I would say education, as has been mentioned. There's a lot of misunderstanding about groundwater, or just total lack of understanding about it. And I think the more you can educate people about groundwater and what the current situations are, the better off we're going to be in terms of choosing wisely among options and taking action where needed.
And part of this, I totally agree with what Ken and Bill are saying, and I think sort of following up on both, in addition to understanding groundwater use, understanding and measuring stream flows. It's not a given in many states, and understanding that connection between groundwater and surface water and being able to model it with some confidence so that we can evaluate the management options that we are looking at requires that we have data on stream flow. And in many places, we don't have the density of networks that measure stream flow currently that we would need to really understand a groundwater surface water connection.
Great, thank you. Well, that's unfortunately all the time we have for questions today. If you have questions that were not addressed, you can email them to us at cipinfo@americangeosciences.org, and we'll make sure to send our questions along to the speakers, so if they have the opportunity to answer them, they can do so.